All right, just a minute, we're outside college physics. We're gonna be looking at a little problem involving vector addition. So let's just go ahead and get started here. A couple vectors here. A hat, 8 at 75 degrees, 8 units of something, and B hat, 12 units at 30 degrees. We want to form A hat plus B hat. So here's the problem. All right, so we go ahead and say A hat plus B hat is equal to C hat is equal to what? What is C hat? In unit vector notation, that is a magnitude and a direction. So first off, we'll get it in unit vector notation. And actually, to begin with, I'll just go ahead and draw this out, right? So it will be a rough drawing of it, but drawing nonetheless of what we've got going on here. So we've got our X, Y plane there, and we'll go ahead and take ourselves this A hat, translate it over here, and say that looks like something about like that. And then we'll take our B hat and translate it over here, and say that looks like something about like that. 8, 12, maybe a little bit longer, but we'll live with it. All right, so we've got ourselves an A hat, we've got ourselves a B hat, and now we've got ourselves a C hat too, which is A hat plus B hat. All right, so we've got our A hat, B hat, and then our C hat. So the C hat has some X components, Y components. What do we need to do? We need to figure out what they are, right? Should we just add 8 plus 12 and say, hey, it's 20? And the answer is definitely not. You can't just add magnitudes. These are in different directions. If they're going to be the same direction, then that's okay, but that's not the case here. So what we need to be able to do is first get A hat and B hat written in unit vector notation. That's the first step. Make sure we get the vectors in unit vector notation. So how are we going to do that? Well, pretty easy. We're just going to resolve both of these. We know that A sub x is equal to the magnitude of A times the cosine of theta sub A, which is then 8 times the cosine of 75 degrees. A sub y is equal to the magnitude of A times the sine of theta sub A, which is then 8 times the sine of 75 degrees. We know that B sub x is equal to the magnitude of B times the cosine of theta sub B, which is then magnitude 12, cosine of 30 degrees, and B sub y is equal to the magnitude of B times the sine of theta sub B, which is then 12 times the sine of 30 degrees. What do? We can just go ahead and roll down this, compute these all out, calculator it in degrees, and we've got 8 cosine 75, 8 sine 75, and 12 cosine 30. And from this, we get 2.0706, 2.0706 for A sub x, A sub y, 7.727, 7.7274. All right, and then we've got B sub x is 10.392, 10.392, and this sine of 30 is just 1/2, so 6.0000. There we go. There's our X components and Y components. So ultimately, we can write out what A sub X and A sub Y, A hat and B hat are in unit vector notation. And do you really need to? No, but I'm going to anyway. So we have that A hat can also be written as 2.07 2.06 I hat plus 7.7274 J hat, and B hat is equal to 10.392 I hat plus 6.0000 J hat. There we go. We got those two vectors written in unit vector notation. Ultimately, we just need to know what are the x and y components, right? Because when we go ahead and start forming ourselves C hat is C sub x I hat plus C sub y j hat. There's C hat in unit vector notation. So the question becomes, what is C sub x and what is C sub y? Well, we've already done that. C sub x is equal to A sub x plus B sub x. A sub x, 2.0706, 2.0706. B sub x, 10.392. C sub y, well, that's A sub y plus B sub y, where A sub y is 7.7274 plus 6.0000, which is just going to be 13.7274, 13.7274. And this one, I'll just stick that in the calculator really quick. Life easy here. We got that plus 2.0706. That's 12.4629. 12.4629. There we go. We've got the x and y components of C hat. Thus, in unit vector notation, C hat can be written as 12.4629, 12.4629 units in the I hat direction, plus 13.7274 units in the j hat direction. If we wanted to see that, what that really means, right? Just go ahead and say that's this and this. This is C sub x I hat, this is C sub y j hat. We've also got this theta sub c there, and that comes to the next part, right? Hey, what is the vector C hat written as a magnitude and a direction? So, for part B, we've got that C hat being equal to the magnitude of C at theta sub c is what we want. So, what do we do? Well, we've got that the magnitude of C is equal to the square root of C sub x squared plus C sub y squared. We know what C sub x and C sub y are. They're right here. A sub x plus B sub x and A sub y plus B sub y. So we've got the square root of 12.4629. 4629 quantity squared plus 13.7274. Quantity squared. And let's just go ahead and throw that in. Square root of x squared plus 13.7274 squared. Plus 13.7274. We get ourselves 18.5409. 18.5409 units is the total magnitude of the vector C hat, and theta sub c is gotten by looking up arctangent of C sub y over C sub x, which is then arctangent of 13.7274 divided by 12.4629. And we got ourselves arctangent of 13.7274 divided by 12.4629. 47.764 degrees. 47.764 degrees. Thus, in the end, we've got ourselves C hat is equal to, let's just call it 18.5. 18.5 units at an angle of 47.8 degrees. Assuming 3 significant figures there. And there we go. So ultimately, first step, get everything in unit vector notation when you're adding vectors together. Figure out what the sum of the x components and the sum of the y components are. Square root of the sum of the squares, arctangent of the sum of the y with the sum of the x. Gives us magnitude and direction. And this is going to be a very common theme throughout this course, adding vectors together. So it's very systematic. Takes some time getting used to if you're not familiar with it, you haven't done it before, but it just takes a little bit of time. Let's go through the steps, get the steps down. All right, let's look at one more piece of this puzzle, and that is, hey, what is the resultant vector d hat, which we're going to say is a hat minus b hat. Uh-oh, we're going to subtract a hat, subtract b hat from a hat. So there's a hat and there's b hat. Let's erase this stuff. I'm going to keep this. Almost erased it all. Not quite. I still got them in unit vector notation. That is going to be helpful. All right, so it comes into now, we want d hat, which is a hat minus b hat. Subtract vectors. Shoot. Did we go over subtraction in lecture? Yes and no. Ultimately, subtraction and addition are the same thing. You add a negative number, it's the same thing as subtracting the positive of that number. So really, we've done it. It's addition. That is to say that this is exactly the same thing as a hat plus negative b hat. So this is how I like to think of it. We're just adding on a different vector, which is the opposite of b hat, which is just b hat rotated by 180 degrees. Same magnitude, opposite direction. So what do we do with this then? Well, if we're just doing vector addition, all we need to do is take the x and y components, right? We've got a hat here, x component, y component. We've got b hat here, x component, y component. If we want negative b hat, well, we've got the minus b hat, looks like that. This vector rotated 180 degrees, and if we want to write this out in unit vector notation, well, that is going to be a negative sign distributed through these two terms. So we've got that is negative 10.392 I hat minus 6.0000 j hat. Negative I hat component, negative j hat component. Pointing in the third quadrant, negative, negative, perfect. So when we go ahead and start looking at this, we can do it. Let's look at it graphically first, and then we'll just put the map together. See what we're actually doing here. We've got an x, we've got a y. We take ourselves a hat, which was 8 at 75 degrees, something like that. And then we're going to add ourselves on negative b hat, this vector here. So we're going to take this and stick it over here. And let's just do that. That's going to look something like this. Negative b hat. A hat plus negative b hat gives us this vector. D hat. Start at the tail of the first vector, end at the tip of the last vector. There's our new vector there, d hat. So, we've got ourselves some things to think about. Here's our theta sub d. It has a particular magnitude. Great. Let's just go ahead and figure this stuff out really quick. So, back here, so we've got a hat plus negative b hat is going to be equal to a sub x minus b sub x plus a sub y minus b sub y in the I hat and j hat directions respectively. Let's just write it like this. We've got this plus this I hat. We've got 2.0706 minus 10.392 I hat. This is a sub x plus negative b sub x. And we've got a plus 7.7274 minus 6.000. 0. J hat. So a hat minus b hat, which is a hat plus minus b hat, is then equal to, in unit vector notation, 2.0706 minus 10.392 gives us negative 8.3214, negative 8.3214 I hat. And then we've got 7.7 minus the 6. So what do we got? 1.7 plus 1.7274 j hat. So this is a hat minus b hat in unit vector notation, which is part C. Last thing to do, figure out what it is in or as a magnitude and direction. So we've got part D. D hat is equal to some magnitude of D hat at some theta sub D. We've got that the magnitude of D hat is going to be equal to the square root of the sum of the squares of its x and y components. Here's D sub x, here's D sub y. So we've got ourselves negative 8.3214 quantity squared plus 1.7274 quantity squared. Square root of square 1.7274. 8.4988. There is the overall magnitude, and then we've got ourselves the direction. Theta sub d is gotten by, again, looking at the arctangent of d sub y or d sub x, which is 1.7274, divided by negative 8.3214. And we stick that in our calculator, and we've got the arctangent 1.7274 divided by 8.3214, negative 8.3214. And my calculator go ahead and gives me negative 11.727, negative 11.727 degrees. There's what my calculator gives me, right? So we ask ourselves, is that right? Well, let's just go over here and reference what we've got going on. Here's the direction that it's pointing. This direction in the second quadrant. Negative 11 would be down into the fourth quadrant. So what's going on here? That's not pointing into the fourth quadrant. Second quadrant. Well, what do we have? The x-component's negative. The x-component's negative, you are going to have to add 180 degrees onto the answer. So we have to add plus 180 degrees since d sub x is negative, and that gives us 168.2 168.273, 168.273 degrees. When we look at that, you say, is that reasonable? 168, well, there's 180. 168, that seems reasonable to me. So, there we go. Have to be paying attention though. Don't just say what the calculator gives you is always correct, especially when using arctangent trying to figure out angles. Always double check. Look at the x component, is it negative? Look at the x and y, what quadrant are you in? Negative x, positive y, that's the second quadrant. If you're ever in the second or third quadrant, your calculator is always going to put you in the first or fourth. So you have to be at 180 degrees if using arctangent. In the end though, we've got ourselves part B. D hat is equal then to 8.50 at 168 degrees. Three significant figures there. There we go. So here's one last little question, a little bonus question here. And that would be, does order of addition matter? So here's the is A hat plus B hat the same thing as B hat plus A hat? Well, think about it. All we're doing is adding x components to x components, y components to y components. We have that A hat plus B hat would be some A sub x plus B sub x I hat plus A sub y plus B sub y j hat. And the question is, does that equal B hat plus A hat? Well, B hat plus A hat would be B sub x plus A sub x I hat plus B sub y plus A sub y j hat. These are just really numbers, right? Numbers have some direction associated with them, but that's outside. These are both in the same direction, or along the same dimension, you should say. Ultimately, you should be able to say that A sub x plus B sub x is the same thing as B sub x plus A sub x. And same thing for the y components. So the answer to this is yes, they are the same. Order doesn't matter. Order of addition with vectors does not matter, just like it doesn't with regular scalar quantities either. So, just a little bonus. There we go. All right, hopefully that sits well. And again, we're doing a whole bunch of vector addition. So practice it. Practice, practice, practice. Get it down. All right, have a good one.